Group 3. Welcome to our vlog entitled The Amazing Math Hidden in Nature. Many people think that mathematics only exists inside classrooms, but today we'll show you that math can actually be found all around us, in plants, flowers, animals, and even in our own surroundings. Today, we're going to explore how mathematics appear in nature through the Fibonacci sequence, pattern in nature, and the golden ratio.
And each of one of us will explain one topic to understand how math connects to the modern world. So let's get started, guys! Have you ever looked around and noticed that nature has its own way of creating beautiful designs? At first, they might seem random, but when you pay closer attention, you'll realize that many plants and living things follow repeating patterns. Notice how each leaf grown from the center and is arranged evenly on both sides. This repeating arrangement isn't just beautiful. It helps every leaf receive enough sunlight and allows the plant to grow properly. And now let's look at this flower. The petals are arranged in a balanced and organized way around the center. This pattern doesn't just make the flower attractive, it also helps attract pollinators like bees and butterflies, which are important for reproduction. Here's another flower. Instead of having just one large bloom, many small flowers grow together in a cluster. The repeating arrangement makes the plant more noticeable to insects and give its beautiful, organized appearance. This yellow flower also shows a repeating pattern. Its petals spread evenly around the center, creating a shape that looks balanced and symmetrical. Nature often repeats simple designs like these because they are both efficient and beautiful.
Let's first understand how the Fibonacci sequence works. The Fibonacci sequence is a pattern of numbers where each new number is found by adding the two numbers before it. It starts with 0 and then 1. If we add 0 plus 1, we get 1. Then we add 1 plus 1, which gives us 2. 2 plus 1 is 3. And 2 plus 3 is equals to 5. After that, 3 plus 5 is 8. 5 plus 8 is equals to 13. 8 plus 13 is 21, and so on. So the sequence becomes 0, 1, 1, 2, 3, 5, 8, 13, and 21. Basically, it is a list of numbers. The rule is actually very simple. To get the very next number, you just need to add the two numbers before it. It may seem just like a number pattern at first, but what's amazing about this is that this same sequence appears in many parts of nature, like flowers, pine cones, sunflowers, and even pineapples. That's why the Fibonacci sequence is considered one of the most fascinating patterns found in the natural world. The Fibonacci sequence appears in the arrangement of leaves, flower petals, pine cones, pineapples, and sunflower seeds. These patterns help plants maximize sunlight exposure, pack seeds efficiently, and optimize space. The golden ratio, on the other hand, emerges when the ratio of consecutive Fibonacci numbers gets larger. It can be seen in spiral shells like conch shells, in hurricanes, in galaxies, and in the spiral arrangements of seeds and petals of a flower. These spiral patterns often follow the golden spiral, allowing for efficient growth and natural balance. And did you know that this very same golden spiral can be seen in our body? All you have to do is look in a mirror and look over here. our ears. The spiral of the human ear, particularly known as the cochlea, is often compared to the golden spiral because of its coiled shape. As the cochlea spirals inwards, its form resembles the logarithmic spirals seen in nature, such as seashells and the eye of the storms. Although the human cochlea is not a perfect golden spiral, its structure is an efficient design that allows a long sensory membrane to fit into a compact space, enabling the ear to detect a wide range of sound frequencies. This connection shows how the golden ratio and Fibonacci-inspired spiral patterns are reflected in biological structures, where spiral shapes provide efficient organization and function rather than being exact mathematical copies.
Have you ever looked at a flower, a building, or even a famous painting and thought, why does this look so pleasing to the eye? Well, there is actually a mathematical idea behind that, and it's called the golden ratio. Now, the golden ratio is a special proportion that has been used in nature, art, architecture, and design for centuries. It's often represented by number 1.618. And now, don't worry, you don't need to memorize the number. What's important is that the golden ratio describes a relationship between two parts when the smaller part relates to the larger part. In the same way, larger part relates to the whole. Sounds complicated, right? But here's the simple version. It's a proportion that many people find naturally balanced and visually appealing.
Let's start with flowers. If you closely look at some flowers, you'll notice that their petals are arranged in a way that helps them receive sunlight efficiently and attract pollinators. Many of these arrangements are connected to the golden ratio and Fibonacci sequence. Sunflowers and spiral plants are great examples. Their seeds and leaves grow in a spiral pattern that helps maximize space and make growth more efficient. The golden ratio can also be found in architecture. Many famous buildings use proportions that are close to the golden ratio because they create a sense of balance and harmony.
Wow!
Even if people don't know the math behind it, they are often find this design attractive.
So why does this matter? These patterns help us understand the world. Architects use the golden ratio in creating a buildings, designing a buildings, and artists use it in paintings. Wow! And scientists use it in studying plants and animals. So learning about this made me realize that math is not just about solving numbers. It helps us explain why things are the way they are. And math connects us to nature in a deeper way.
After exploring our surroundings, we discovered that mathematics isn't limited to solving equations. The Fibonacci sequence helps explain Efficient's pattern of growth, while the golden ratio represents proportion that frequently appear in nature. These mathematical ideas allows plants and other living organisms to grow in ways that maximize space, sunlight, and efficiency.